Hello, this one's for my geometry students. Welcome back. Continuing our series on proofs. If you haven't taken a look at the earlier two videos, feel free to do so now or do so at the end of this video. The more proofs you are exposed to, the more tools you have in your tool bucket. All right, let's get to it. Okay, let's examine what we're working with today. All right, so again, we see a triangle, but we also see possibilities for lots of overlapping triangles here, yeah? All right, given XC is congruent to BY, so that's this long side is congruent to this long side. All right, so maybe I'm gonna mark that kind of up here. All right, triangle ZBC is isosceles. ZBC. Okay, so that tells me isosceles means what? Good. It means we have two equal angles. And it also means the sides opposite those angles are equal. So that means we know that the long sides are congruent. We also know that these bits are congruent. And is anybody putting that together? Right? By subtraction, we also would know that these guys are congruent. So we have a lot of information there. Triangle ACB is isosceles. ACB is isosceles. So that means, everybody think about it, right? That means we have these two long sides are congruent. And it also means that our two base angles are congruent. All right, and finally, we want to prove that triangle AXC is congruent to triangle AYB. All right, so we examined our givens as we went along, kind of put that into the picture. Now let's examine what we want to prove and start to bring those two closer together. So we see these triangles, and we see that each of the triangles we're being asked to prove we already know a side of, right? And in fact, we also already know an angle because angle A is involved in both triangles. So we have angle side, and so we either need another side, angle side, or we need another angle. Okay, is anybody seeing it? And again, I want to remind you, there are lots of ways through. So if you see something that's different than what I'm about to do right now, please pause the video, follow it through, and see if you can take it to the end. In fact, put it in the comments if you want. Take a picture. I'd love to see it. But here's what I see. We have angle, we have side, and we want this angle, and I see right now that we have it. We have that these guys are congruent because that guy was isosceles. We've got that these guys are congruent because that guy was isosceles, which means by subtraction, we're going to have that angle is congruent to that angle. And there is our angle, side, angle, angle, side, angle to prove what we want to prove. So now let's lay it out. Ready? Okay, so first we're going to put in our givens. We've got that. Gosh, and did we even use this first given? X, C, and BY. I'm not sure we even used those. So that's fascinating. But you can see we could have gone side, angle, side. So again, lots of ways through. But with the way I laid out, I never even used this given. So I'm not going to put it in. Okay, but I am going to put these guys in. So triangle ZBC is isosceles, and that's because given. And what I'm going to do actually is right after I name that that's isosceles, I'm going to name that these angles are congruent. So I'm going to say that angle ZCB is congruent to angle ZBC. and that's def isosceles. Now I'm going to put in my other one. Triangle ACB is isosceles. And by the way, if you like to name all your givens first and then say this stuff, that's fine too. There isn't a wrong order here. So that one was because given. And then I'm going to say the same thing. So from triangle ACB being isosceles, I have two important pieces of info. The first is that those sides are congruent, right? So side AC is congruent to side AB, and that was def isosceles. And then I also have that angle ACB is congruent to angle ABC. And that's also because of def isosceles, right? Isosceles means two equal angles and two equal sides. Okie doke. So now, again, depending on how picky your teacher is, you may need to say that angle C is made up of ACX plus XCB, to then say that angle ACX is going to, and you'd set it up on the same side, that ABC is made up of ABY plus YBC, and then land at the statement that through subtraction, ACX is congruent to ABY because of subtraction. And so now I can put my final piece in, which is that angle A is congruent to angle A because of reflexive property. And so finally, I've got that triangle AXC is congruent to triangle AYB because of angle, side, angle, angle, side, angle. Okay, so that's one way through. Another way through would have been to use this piece of given and say that side angle side is the reason these guys are congruent. Yeah? Or another way, if I were the teacher, I might have actually asked you to prove that XC is congruent to BY. And so I would prove the triangles were congruent, and then by CPCTC, I would know that these are congruent. So you can see this stuff all, I get excited, this stuff all intersects in interesting ways, especially the overlapping triangle problems. Okay, so that's another example of a proof. I invite you, if you see a different way to get there, go ahead and write it up. Snap a picture of it, pop it into the comments. Everybody's going to grow from that. And then meanwhile, watch the video again, pause before I give the answer, see if you can come up with it first. And as always, keep on mathing.